Welcome back to AI Trekkers.
Hey, everyone.
Today, we're kind of jumping off this recent Nobel Prize in physics.
Yeah,
There's a lot of celebration, obviously.
of course.
John Hopfield, Geoffrey Hinton, huge names.
Huge contributions.
But there's this kind of undercurrent of, I don't know, maybe frustration's a strong word,
Mm.
coming from especially researchers in Japan
Yeah, I've seen that.
who are saying, hold on, there's some big names missing from this story.
It's like a piece of the puzzle is missing, right?
Exactly.
When you look at the history of AI and who was doing what, when.
And the source material we've been digging into highlights three names specifically:
Yeah, I'm looking at them right here.
Shunichi Amari,
Right.
Kunihiko Fukushima,
Yep.
and Takayuki Ito.
Really foundational researchers.
So let's unpack this a little bit.
Okay.
Amari, this is going way back,
Way back.
1967. He's developing a method for neural networks to learn, to adapt from data,
That's before a lot of our listeners were even born.
probably.
But he's already working on the core concepts, and I think that's what people are pointing to. Like, this is directly relevant to what Hinton won the Nobel for.
Yeah.
This idea of backpropagation, how neural networks learn. Amari was there.
It blows my mind to think about that.
Yeah.
1967, the computing power, or lack thereof,
Oh, yeah, it was a totally different world.
and yet these ideas, they were already taking shape.
They were there.
Makes you wonder, was there any communication between, like, the West and Japan on this stuff?
Right. Were they building on each other's work? Or was it totally separate tracks?
Because from what I'm seeing, it was like two different philosophies developing simultaneously.
Totally. You had the West very focused on symbolic AI, like rule-based systems, logic-driven.
Right.
And then you have this, like, human science approach in Japan.
YouTube talked about that.
Yeah.
They were really looking at biological systems, like trying to model the brain.
Makes you think, what if those two worlds had come together back then?
What would AI look like today?
Right. A total different landscape, I think.
So you have Amari laying this groundwork, and then Fukushima
He takes it to the next level.
creates the first multi-layer convolutional neural network in 1979.
Every AI student today, convnets are like their bread and butter.
The foundation of so much of what we do.
Image recognition, natural language processing, it all comes back to that.
And he was doing it by modeling the visual cortex, like literally trying to replicate how the brain sees.
He wasn't just throwing math at the problem.
He was trying to understand the underlying biology, the mechanisms of intelligence.
Which, again, it goes back to Ito's human science idea.
Yeah. And it makes you wonder, what are the implications of that difference in approach?
Right, because the Western statistically driven approach, it's given us some really powerful tools.
No doubt.
But have we sacrificed something along the way, like a deeper understanding of what intelligence actually is?
Yeah, that's a really good question. And I think for our listeners, that's the takeaway here.
Uh,
It's not just about giving credit where credit is due,
Right.
though that's important.
Definitely.
It's about understanding that AI isn't this monolithic thing.
Yeah, there are different paths, different ways of thinking about it.
And maybe some of these less explored paths, they hold the key to the next breakthrough.
Like, who knows what's out there waiting to be rediscovered, what might have been overlooked or forgotten.
Right. Because AI history is full of these little side roads.
Absolutely.
And if we're not careful, we might miss the turn that leads to something amazing.
That's a great point. We need to stay open to these alternative narratives.
Exactly. So for everyone listening, keep exploring, keep digging.
Yeah, who knows what you might find out there in the AI universe.
Thanks for following AI Trekkers
See you on our next adventure.
across the AI universe.
Hi, everyone.